I'm Erica De Leon. I'm going to be explaining these problems. First one is a difference quotient problem. We have fx equals negative 5x to the third plus 2x. I've written down the formula. Difference quotient equals f x plus h minus fx over h. You're gonna need to plug in wherever you see x of h. I've got it written here on the back. Wherever you have an x, and let's see, yeah. So it's f x plus h. It's gonna be negative 5 parentheses h plus x to the third. And then you're gonna plus 2 and then h plus x in parentheses again. Then from there you have the parentheses. Inside is that whole problem there, the minus 5 parentheses x plus h, close parentheses to the third plus 2 parentheses x plus h parentheses close parentheses minus, and then you have that same problem, negative 5x to the third plus 2x. Then you're going to put 1 over h, and you're gonna have 2h plus x, 5x to the third minus your 5h plus x to the third. Your difference quotient equals fx minus 5 or negative 5x to the third plus 2x, and your answer is gonna pretty much stay the same as this one. That's really what it is. It's just moving it down. Yeah, so there's that one. Cleared that out. I know some people use the FOIL method or something like that to figure it out. So this is pretty much just what I did. I followed the steps, and you plug in x plus h wherever you see an x up here in the problem. No, that's me. You can see me. I don't know how to get this camera to turn around. Okay, the second problem is going to be a composition problem, where you have f of g of x, and you pretty much replace, you have your, that's easier. You have your problems on top. X2 minus 5x is what f of x equals, and then you have g of x, and that equals x2 plus 3x plus 4. So you're pretty much going to write in the x2 plus 5x here, and then your g of x, you're going to write x2 plus 3x plus 4. And you are going to multiply those. I have it over here. There you go. You get x2 plus 3x plus 4 in your parentheses, and you have minus 5 or negative 5 parentheses x2 plus 3x plus 4, and you get x4 plus 6x3 plus 12x to the second plus 9x minus 4. And you'll continue to do the same thing for each problem. You're basically just substituting what the f and the G, or the G and the F, and switch it back and forth. And so you can see down here, problem C, it's F and F. So it's basically going to be, you know, x2 minus 5x and x2 minus 5x, and you know, you just do the math and you've got it there. Pretty easy, it's not that complicated. I mean, I hope I got it right. And that was for composition. Let me see, for number 3, the third problem I have is a rational root theorem. This one is pretty hard for me because it takes a lot of work to figure out which is your possible rational roots and your actual rational roots. Let me see if I know how to explain this here. You got to find all the potential rational roots, find all the zeros. So in this problem, you have the trailing coefficient is -9, so you're going to find all of its factors, which is, you know, 1, 3, 9, positive or negative. Then you're going to, later on, you're going to find, to check and see which one of those is going to actually equal you to 0, like it says up here. It has to equal to 0. Your leading coefficient is 2, so you are going to find this 2 right here. You are going to find the possible values of the factors of that, which is 1 and 2, -1, -2, +1, +2. So here you're finding all the positive values. You have P of Q, which is, you know, ±1 over 1, ±1 over 2, ±3 over 1, 3 over 2, and etc., etc. Simplify, remove duplicates. So that's what I did there. Your P of X, which is X minus A, should be equal to 0. So you're going to divide X minus 1, as you can see I did there. The quotient is 2x3 plus 7x2 plus 10x plus 25, and the remainder is 16. You got to do this to every rational root until the remainder is 0. And for this problem, I found that all possible rational roots are, there's quite a few of them there, and the actual roots are 1/2 and -3 on this problem. So this one takes a little bit of more explaining, and you know, it's a lot, but it's doable, and it's not that complicated. So there's my response to these 3 questions.